Hello everyone, welcome back to our channel. So Shomu sir, what are we discussing today?
Yeah, we have a very straightforward, simple question, although it would be classified under the area of geometry because it's something to do with volumes and surface areas. But to some extent, we are using basic ideas of ratio and percentages also. So let's get into the question first. We have a solid metallic cube. So it's a cube, solid one, is melted to form 5 solid cubes. So one big cube is basically melted to form 5 solid cubes whose volumes are in the ratio B. So the volume ratio of the small cubes have been given. The percentage by which the sum of the surface area of these 5 cubes exceeds the surface area of the original cube is nearest to. So if you look at the problem holistically from the objective point of view, we're looking something related to surface area, but what are we looking about? I mean, what we're trying to find about it? We are trying to figure out the percentage change in the surface area from the original cube to the new cube, something like that, right? So whenever we have to think in terms of percentages, even the information that is provided is in terms of ratio, the actual value do not matter, right? So we can take convenient values which satisfy the relation. So this is the main relation out here. So that is a volume relation. Okay, we'll come back to that. But where does this volume come from? It comes from the original cube, right? The large one. So what I'm going to do is I'm going to assume the volumes to be these numbers, as simple as that. So if I add these volumes, that should be the total volume of the original cube. Now, what is this? Yeah, so what is this? So 1 plus 1 plus 8 is 10 and 27 twice is 54. So 10 plus 54 is 64, right? So if I assume the volumes of the small cubes as these, the original volume should be 64. Now let us relate. So we had a large cube to begin with, and we have some small cubes, right? After the breaking is done or something. So what about the side or sides of the respective cube? So the large cube has a volume of 64. So the side should be 4. What about the small cubes? So the first two have both side of 1 and 1. The third one, the volume is 8. So the side should be 2. The next two have each volume of 27. So each of them should have a side of 3, right?
Right.
Now, what is the surface area? So surface area of any cube is basically 6a square. So if I consider any cube, each surface is a square, right? There are 6 surfaces. Each surface is a square having side A. So each surface is having an area of a square. So total surface area is 6a square. So if I think about the total surface area, I have to think about it because that is what the context is. So the large cube, we have a total surface area of 6 into 4 square. Now, what are we looking for? We're looking at the percentage by which the sum of the surface areas of these 5 cubes, right? So we have to figure out the total surface area of all these small cubes combined. So that would be 6 into this square plus this square, something like this, right? So I'm just writing this together. So we have something like this as the sum of the surface areas of these small cubes. Now, since we're looking for percentage change, I mean, think about it. I mean, the main context is always ratio, right? When it comes to percentage changes. So when you take a ratio of these two numbers, the 6 will automatically go off, right? That will not impact the percentage change because both have 6 in it. So what I'm going to do is I'm going to focus on the numbers which is apart from 6. So here it is 16. And here this total would be what? 1 plus 1, that is 2, plus 4, that is 6. And then you have a couple of 9s, which is 18 in total. So 6 plus 18, so that is 24, right? So we are looking for a percentage change from 16 to 24. So that is 8 out of 16, which is 50%. And that is our required answer.
Nice. This was pretty simple.
Pretty simple, yeah. Pretty simple.
But an interesting one, I would say.
Yeah. I mean, it combines the idea of ratio along with the geometry idea we're looking for.
Correct.
And if we have any kind of questions related to ratio, percentages, and stuff like that, everything, I mean, the question is the information and the objective has to do with ratios and percentages. So those kind of questions are actual value actually doesn't matter, right? I mean, only thing that matters is maintaining the relationship that has been provided. So as long as you maintain that relationship and take adequate numbers, that's it. Simple.
Correct.
Yeah.
So thank you, sir. Thank you so much for this wonderful question.
Yeah. Thanks, Rachel.
Thank you everyone for joining in.
you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.